What we will learn today is first about uh, tangent planes and differentials, and then after that we will learn about extreme values and saddle points. Jadi pagi ini kita akan belajar tentang bidang singgung, ya, tangent planes, bidang singgung, and differentials, dan hampiran. Jadi bagaimana kita bisa menghampiri nilai dari sebuah fungsi. This is related to linearization that we have learned before the midterm exam. Jadi ini sangat berkaitan dengan linearisasi atau hampiran yang kita pelajari sebelum UTS. But now we will learn about it for at least 2 or 3 variables. And then we also learn about extreme values, saddle points, but we will learn about them for functions of 2 variables in this case. Yeah. So let's start our first part of the materials. That is about tangent planes and differentials, and these are the materials for this first part of this morning. So, first, we will learn about tangent planes and normal lines. What is actually a tangent plane and normal line of a surface? Yeah. So this is the definition. The tangent plane at the point P0, x0, y0, z0 on the level surface f, x, y, z. Yeah, f is a function of x, and y, and z. And the level surface is where the function is constant. Yeah, so f equals some constant c, and f here is a differentiable function. Then the tangent plane is the plane through the point P0 that is normal to the gradient of f at P0. Jadi bidang singgung itu pada dasarnya kalau kita mau mencari bidang singgung, ya kalau di dimensi 2 yang kita cari kan garis singgung, ya. Kalau dimensi lebih tinggi, yang kita cari adalah bidang singgung. Nah, bidang singgung kalau kita mencari bidang singgung pada sebuah titik P0 di sebuah level surface f, x, y, z sama dengan konstanta c, di mana f ini adalah fungsi yang differentiable, ya. Jadi dia fungsi yang punya turunan. Maka bidang singgungnya adalah bidang singgung yang melalui titik P0 dan normal. Normal itu tegak lurus, ya. Tegak lurus terhadap gradien dari f di titik P0. Gradien ini yang mana yang kita pelajari di minggu lalu. And then the normal line of the surface at the point P0 is the line through P0 and parallel to the gradient of f at that point. Ya, jadi garis normalnya adalah garis normal dari permukaan tersebut, ya, di titik P0 adalah garis yang melalui titik P0 dan paralel terhadap gradien, ya, grad f di titik P0. Then the formula is like this, ya. The tangent formula is the top one and the normal line formula is the bottom one. Jadi kita punya rumus dari bidang singgungnya yang atas, kemudian rumus dari garis normalnya yang bawah. Nanti kalian bisa dalami lagi di slide-nya kalau sudah saya upload. Ketika nanti saya upload, ya, ketika saya sudah upload nanti. And now let's just jump to the first example. Find the tangent plane and normal line of the level surface of this is actually a circular paraboloid at the point P0, 1, 2, 4. How do we do that? First, what we need to do is to find grad f. Grad f in this case is a vector of dou f. Let me use this. Dou f dou x dou f dou y dou f dou z, which is 2x, 2y, and 1. And so in this case, we can evaluate grad f at the point P0, which is the vector 2, 2x, 2y, and 1 at point 1, 2, 4, which is 2 times 1, 2 times 2, and 1, which is 2, 4, 1. Yeah. Or you can also write this in terms of I, j, and k like this. 2i plus 4j plus k. Yeah. Then the tangent plane. Oh, tangent plane is therefore we follow this equation. Yeah.
Jangan mau gelapin lampunya. Udah nggak bisa.
So the tangent plane is we follow this equation. Yeah. So the tangent plane is therefore fx p0 is basically 2. 2 times x minus x0 is 1 plus fy p0 is 4 times 1 y minus y0 is 2 and fz p0 is 1, so 1 times z minus z0. Yeah. Z minus z0 is 4 equals to 0. Yeah. Or in this case, we have that the tangent plane is the equation 2x plus 4y plus z equals 14. And the line normal to the surface at P0 is, we follow again the equation that we have. X is equal to 1 plus 2t, and y is equal to 2 plus 4t, and z is equal to 4 plus t. Yeah. Any question? Any question?
I see no, sir.
Okay. Now we go to the next material that is about estimating change in specific direction. Yeah. So to estimate the change in the value of a differentiable function f, when we move a small distance ds, and this is the movement from a point p0 in a particular direction u, we use the formula this, yeah. df, or the change of f, df is the change of f, is the directional derivative grad f at p0 dot product, yeah, grad f of at p0 dot the vector normal, the direction u, times the distance increment, or the change in the distance ds. That is the formula. So let's go to the example. So here we are asked to estimate how much the value of f will change if the point P moves about 0.1 unit from P0 and straight forward to P1. So now here the direction is from P0 to P1. So we have to find the direction, yeah. P0, P1, the vector is basically uh, 2 minus 0, 2 minus 1, minus 2 minus 0. So the vector is 2, 1, minus 2. Then the direction of the vector P0, P1 is u, which is equal to P0, P1, yeah, the vector P0 to P1 divided by its length, yeah, divided by the norm of P0, P1. And the length of P0, P1 is the square root of 2 squared plus 1 squared plus minus 2 squared, which is 3. So it means that the direction is 1 over 3 times the vector P0, P1, which is 2, 1, minus 2. So now, we still need one more ingredient, which is grad of f. Grad of f is the vector dou f dou x, dou f dou y, dou f dou z, which is derivative of f with respect to x is actually y cos x, and derivative of f with respect to y is sine x plus 2z, and derivative of f with respect to z is 2y. So in this case, if we evaluate grad of f at p0, meaning that we have to evaluate y cos x sine x plus 2z and 2y at the point p0, because we move 0.1 unit from p0, yeah, so we evaluate at p0, which is at 0, 1, 0. In this case, we will have cosine of 0 is 1 times 1, 1, 0 plus 0, 0, 1. Oh, sorry, not 1. 1 times 2. Yeah, so it's 2. So now we have all the ingredients. So in this case, we have that df is grad f evaluated at p0 dot product with the direction u multiplied by d s, which is now in this case we have the vector 1, 0, 2 dot product with the vector 2 over 3, 1 over 3, and minus 2 over 3, multiplied by the movement, which is 0.1. So in this case, we have 2 over 3 minus 4 over 3 times 0.1, which in this case we have minus 2 over 3 times 0.1, which is about minus 0,067 unit, ya. Jadi prosesnya sederhana ya. Jadi prosesnya adalah kita cari tahu dulu ya arahnya kemana, dengan cara kita carikan ini arahnya dia dari P0 yang menuju ke arah P1. Berarti kita punya vektor P0 ke P1 yang kita cari dengan cara seperti ini. Kemudian kita cari arahnya. Arahnya itu, ingat, arah itu selalu vektor satuan ya. Jadi arahnya adalah P0 P1 dibagi dengan jarak dari P0 ke P1. Nah, kemudian kita perlu juga cari gradien dari f di titik tersebut ya. Jadi grad f di titik tersebut adalah ini. Ya, ternyata 102. Baru kemudian kita tinggal masukkan rumusnya, ya, rumus yang kita punya di sini. Selesai. Any question? Ada pertanyaan?
For me, no, sir.
Oke.
Yeah, it's great, sir.
Then now we talk about linearization of functions of two variables. This is the definition. Yeah, I think you remember this from before the midterm exam about linearization. The linearization of a function of two variables f(x, y) at the point x0, y0, where f is differentiable, is the function L, x, y expressed in this form. And this approximation is basically called as the standard linear approximation of f at x0, y0. So let's jump to the example. Find the linearization of this guy at the point 3, 2, and let me also put the formula here. So the ingredients that we need here are fx, derivative of f with respect to x, yeah, which is dou f dou x, which is 2x minus y, yeah, that's all, and fy, which is dou f dou y, that is minus x plus y. So now we have that f at f at the point 3, 2 is 3 squared minus 3 times 2 plus half of 2 squared plus 3, which is 8, and fx at 3, 2 is 2 times 3 minus 2, which is 6 minus 2 is 4, and fy at 3, 2 is minus 3 plus 2, which is minus 1. So in this case, the linearization is L x, y is equal to fx0, y0, which is 8, plus fx x0, y0 is 4 times x minus x0, so x minus 3, plus fy x0, y0 is minus 1 times y minus 2. Yeah. Or we can simplify this expression as 4x minus y minus 2. Any question? Ya, jadi kalau mau mencari linearisasi, simple ya. Kita tinggal cari turunan terhadap x, turunan terhadap y, ya, untuk fungsi dua variabel. Kemudian kita evaluasi fungsi tersebut, turunannya terhadap x dan turunannya terhadap y di titik yang kita mau linearisasi itu. Kemudian kita tinggal masukkan rumus ini. Ada pertanyaan?
Sir,
Ya?
berarti untuk mencari L itu rumus tetapnya yang fx sama fy itu, Sir.
Maksudnya gimana?
Kalau misalnya kita mau cari L sama dengan yang x, y, kita pakai rumusnya tetap yang x.
Ya
yang,
ini, rumus
ya.
yang ini. Ya.
Itu udah pasti, Sir.
Iya, memang rumusnya ini. Definisinya memang ini.
Oh, oke. Baik, terima kasih, Sir.
Jadi kalau kalian nanti ketemu soal diminta untuk mencari linearisasi dari fungsi dua variabel, kalian tinggal cari rumus ini gitu ya. Oke. Okay.
Okay, sir.
Now, if we do some linearization, ya, jadi kalau kita melakukan linearisasi, itu kan aproksimasi ya. Then in this case, there must be some errors ya between the actual value of the function and the linearized version. Ya. Jadi pasti ada selisih antara nilai fungsi sebenarnya dengan versi terlinearisasinya, versi yang sudah dilinearisasi. Dan that error is actually this guy. Jadi errornya adalah ini, pertidaksamaan ini. So if f has continuous first and second partial derivatives throughout an open set containing a rectangle R centered at x0, y0, and if m is any upper bounds for the values of these guys on R, then the error is this guy. Jadi kalau kita mau mengestimasi kira-kira errornya seberapa, maka kita perlu mencari turunan keduanya semuanya ya. Terus dari turunan kedua itu kita cari nilai yang terbesar. Errornya kemudian tinggal tulis seperti ini dari formula ini ya. For this one the example will be given in the exercise. So now the last part is about differential. First, we talk about total differential. What is actually a total differential? So if we move from the point x0, y0 to a point x0 plus dx, y0 plus dy nearby, the resulting change of df is actually this. And this df is called the total differential of f. Jadi kalau kita mau memindahkan, kalau kita berpindah ya dari sebuah titik x0, y0 ke titik yang dekat, ini dx, dy ini selisih perpindahannya. Ya. Selisihnya di x berapa, selisihnya di y berapa, dan cukup kecil, gitu ya. Makanya di sini ada kata-kata nearby. Maka perubahannya, ya, yaitu df sama dengan ini disebut sebagai total diferensial dari f. For example, suppose that a cylindrical can is designed to have a radius of 1 inch and a height of 5 inch. But that the radius and height are off by the amounts of dr, which is plus 0,03, and dh is minus 0,1. So we are asked to estimate the resulting absolute change in the volume of the can. So to estimate the change, basically first we need to write the formula for a volume of a cylindrical can, which is V equals to PR squared H. So to estimate the absolute change in the volume V, we use dV equals to derivative of V with respect to R at the point R 0, H0 times dr plus derivative of V with respect to H at R0, H0 times dH. And from here, from the formula of the volume, we have that derivative of V with respect to R is actually 2PRH, and derivative of V with respect to H is PR squared. So we get dV equals to 2 PR0 H0 times dr plus PR0 squared dH, which is 2P R0 is the radius of 1 inch, H0 is 5, and dr is plus 0,03 plus P R0 squared. R0 is 1 squared times dH is minus 0,1. And this is actually 0,3 times P minus 0,1 times P, which is 0,2 times P, which is about 0,63 inch cube. Yeah. That's it. Di sini ceritanya kita punya kaleng berbentuk silinder, berbentuk tabung, yang didesain untuk memiliki radius 1 inci dan jari-jarinya 1 inci dan tingginya adalah 5 inci. Ya, tapi ini kan misalkan kita punya perusahaan gitu ya yang memproduksi kaleng dengan jari-jari alas dan tutupnya itu 1 inci dan tinggi dari kaleng tersebut adalah 5 inci. Yang pasti walaupun kita menggunakan mesin kan hampir bisa dipastikan ada ya kadang-kadang kita akan menemukan selisih ya. Selisih ternyata radiusnya atau jari-jarinya itu ada berubah jadi lebih lebar sedikit, lebih lebar 0,03 inci. Dan tingginya itu ternyata berkurang sedikit, ada perubahan sedikit minus 0,1 inci. Dari sini kita bisa mengestimasi kira-kira perubahan volumenya seberapa kalau kita ada perubahan jari-jari dan ketinggian segitu. Caranya adalah kita gunakan rumus volumenya ya. Kemudian kita gunakan ini ya. Rumus dari total diferensial di mana F-nya kita ganti V sebagai volume, X-nya kita ganti R sebagai jari-jari dan Y-nya kita ganti H sebagai tinggi. Ya. Kita balik ke sini, maka kita dapat bahwa dV-nya adalah VR di titik R 0,H0 dikalikan dr ditambah VH di titik R 0,H0 dikalikan dH. Di sini berarti VR ini maksudnya turunan V terhadap R dan VH itu maksudnya turunan V terhadap H. Kemudian kita tinggal masukkan nilainya. Any question? Ada pertanyaan?
For me, no, sir.
No?
No, also no.
Then if not, we go to some exercises. Yeah. The first problem is one of the easiest one. Find the equations for the tangent plane and normal lines at the given point on the given surface if we have this. So in this case, we have that the function f x, y, z is actually x squared plus 2xy minus y squared plus z squared. Then here we have derivative of f with respect to x is 2x plus 2y, and derivative of f with respect to y is 2x minus 2y, and derivative of f with respect to z is 2z. So in this case, we have that fx at p0 is basically 2 times 1 plus 2 times minus 1, which is 0, and derivative of f with respect to y at p0 is 2 times 1 minus 2 times minus 1, which is equal to 4, and the derivative of f with respect to z at p0 is basically 2 times z is 3, which is 6. So in this case, we then use the formula. The tangent plane is fx p0 times x minus x0 plus fy p0 times y minus y0 plus fz p0 times z minus z0 equal to 0. Then in this case, we simply need to put everything in. 0 plus 4 times y minus y0 is minus 1, plus fz is 6 times z minus z0 is 3, equal to 0. And in this case, we have that 4y plus 6z equals to 4 minus 11. Sorry, 4 minus 18, 14. So this is equal to 14. Or we can divide everything by 2. Then we have 2y plus 3z equals to 7. So this is the tangent plane, because we simply need to follow this formula. And the normal line is x equals x0, 1 plus fx0, 0 times t, which is 1, and y equal to y0, that is minus 1, plus fy at p0, which is 4 times t, and z is 3 plus 6t. Yeah. Any question for this first exercise? Kita cuma tinggal pakai rumusnya saja ya. Ada pertanyaan?
So, yang tangent plane.
Ya.
Itu agak bingung sih, Sir. Yang kok bisa hasilnya 7 itu.
Ini kan dari 4y plus 6z sama dengan 14, kan kita bisa bagi 2.
Oh iya. Serius.
Ya. Oke, ada pertanyaan lagi? Ke latihan berikutnya. find an equation for the plane that is tangent to the given surface at the given point if this, yeah. So for this one, first what we need to do is we have z equals ln x squared plus y squared. Then in this case we can make the equation to become like this: ln x squared plus y squared minus z equals 0, and this guy is the f of x comma y comma z. So now we have that fx, derivative of f with respect to x, is 2x divided by x squared plus y squared, and derivative of f with respect to y is 2y divided by x squared plus y squared, and derivative of f with respect to z is minus 1. So in this case we have that fx p0 is 2, and fy p0 is 0, and fz p0 is minus 1. So from here we have that the tangent plane is, we simply put in everything from the formula: 2 times x minus 1 plus 0 plus minus 1 times z minus 0 equals 0. Then in this case we have that 2x minus z equals minus 2, we move to the right, equals 2. Ya. Ya, prosesnya sama ya untuk mencari apa namanya bidang singgung dari surface ini. Ya, maka kita pindahkan dulu semuanya ke sini gitu ya, misalkan ke sebelah kirinya sama dengan semua atau ke sebelah kanannya, sehingga kita dapat fx, y, z. Dari situ baru kita apa namanya turunkan ya. Okay, then the third problem, I have put a hint here because this is a little bit harder than before. Yeah. Find parametric equations for the line tangent to the curve of intersection of the surfaces at the given point 1, 1, 1. Yeah. So how should we do this? The hint is that the tangent vector of the intersection of these two surfaces is perpendicular to the gradient of the surface. So for this one, we need to find the gradient. Yeah. Let's say we have f of x comma y comma z is the function x y z minus 1, and Then from here we have that fx is yz, fy is xz, and fz is xy. Then in this case we have fx at 1, 1, 1 is 1. Also fy at 1, 1, 1 also 1. And fz at 1, 1, 1 is also 1. Now g of x, y, z is the function x squared plus 2y squared plus 3 z squared minus 6. Then we have that gx is 2x and gy is 4y and gz is 6z. Yeah. Then we have that gx at 1, 1, 1 is 2. Gy at 1, 1, 1 is 4. And gz at 1, 1, 1 is 6. So now from here we have that these are the gradients. So the tangent vector of the intersection of the two surfaces is perpendicular to the gradient of the surface. Then here we have that the gradient grad f at 1, 1, 1 is 1, 1, 1. And grad g at 1, 1, 1 is 2, 4, 6. So now what we need to do is to find a vector that is perpendicular to the gradient of the surfaces. So the vector that is perpendicular to both surfaces is basically the vector grad f at 1, 1, 1 cross grad g at 1, 1, 1, which is 1, 1, 1 cross 2, 4, 6, which is the determinant of I, j, k, 1, 1, 1, 2, 4, 6, which is, okay, 6 minus 4, 2i plus 6 minus 2. So 4j plus 4 minus 2, yeah, 2k, yeah. Or we can also write it as 2, 4, 2. Then now we simply need to use the formula for the normal line to get the tangent vector of the intersection of the two surfaces. Yeah. So in this case we use x equals to the point x0 is 1 plus 2t, and then we have y equals to 1 plus 4t t and z is equal to 1 plus 2t. And that's it. Any question? Jadi di petunjuknya sudah ada ya. Di petunjuknya adalah kalau kita mau mencari garis yang yang bersinggungan dengan kurva yang beririsan ya dengan yang garis yang bersinggungan dengan kurva dari hasil irisan antara dua kurva dari dua permukaan. Ya. Kita punya permukaan x, y, z sama dengan 1 dan permukaan x kuadrat plus 2y kuadrat plus 3z kuadrat sama dengan 6. Kemudian kita iris, kita akan mendapatkan sebuah kurva. Nah, kurva tersebut akan kita cari garis singgungnya di titik 1,1,1, maka caranya adalah kita ngikutin ini ya, petunjuk yang sudah saya tulis. Dengan cara kita mencari gradien dari f di titik tersebut, kemudian gradien dari permukaan yang kedua di titik tersebut ya. Setelah kita temukan gradiennya, kita cari vektor yang perpendikular atau tegak lurus ya. Tegak lurus terhadap gradien dari kedua permukaan tersebut ya. Jadi kita cari yang tegak lurus itu adalah cross product. Kalau kalian masih ingat ya, perkalian silang. Perkalian silang antara dua vektor itu akan menghasilkan vektor yang tegak lurus. Yang tegak lurus terhadap kedua vektor tersebut ya. Maka salah satu caranya adalah kita menggunakan cross product seperti ini. Kemudian kita dapatkan hasilnya vektor yang tegak lurus adalah 2, 4, 2. Sehingga persamaan parametriknya kita tinggal masukkan persamaan yang rumus yang ada di sini ya. X sama dengan X0 min itu. Cuman fx P0, fy P0, dan fz P0 itu kita ganti dengan nilai dari ini hasil perkalian silangnya. Ya, ada pertanyaan? Ada pertanyaan?
For me, no.
No, sir.
The next exercise. So for this one, the question is, by how much will the function change if the point p, x, y, z moves from p0 at a distance of this unit in the direction of this? So in this case, what we need to do first, again, we need to find grad f, which is in this case grad f is 1 over square root of x squared plus, let's try to find it in a different way. First we find fx, derivative of f with respect to x, which is 1 over square root of x squared plus y squared plus z squared, and the derivative of that guy with respect to x is so this is this times x divided by square root of x squared plus y squared plus z squared half. Get down times, yeah, I think this is correct. So we have fx is x divided by x squared plus y squared plus z squared, and so fy, similarly we have y divided by x squared plus y squared plus z squared, and fz is z divided by x squared plus y squared plus z squared. Yeah. So in this case, if we evaluate at the point 3, 4, 12, we have, okay, how much? What is the value? 3 divided by 3 squared, which is 9, plus 4 squared, which is 16, plus 12 squared is 144. In this case, we have 3 divided by 169. And fy, if we evaluate at 3, 4, 12, this is 4 over 169. And if we evaluate fc at 3, 4, 12, we have 12 over 169. So now we need to also find the direction u, which is the vector 3i plus 6j minus 2k divided by its length, which is norm of 3i plus 6j minus 2k, which is 9 plus 36. 9 plus 36 is 45 plus 4 is 49. So this is 3 over 7 I plus 6 over 7 j minus 2 over 7 k. So finally, we just need to follow the formula. This formula. So basically, this is the vector we have there, 3 over 169. 3 over 169 and 4 over 169 and 12 over 169, dot product with 3 over 7, 6 over 7, and minus 2 over 7. Times the distance increment is 0.1 unit. Which in this case we have 3 over 169 times 3 over 7 plus 4 over 169 times 6 over 7 plus 12 over 169 times minus 2 over 7 times 0,1. Then we have here 9 plus 24, which is 33, minus 12 times minus 24, so 9. 9 over 169 times 7 is 1183. We multiplied with 0.1, which is this is approximately 0,0000760. Sorry, that's all. Unit. Yeah. Any question? Ya. Karena kita diminta untuk ya kira-kira berapa sih perubahannya gitu ya. Kita cari turunan F terhadap X, turunan F terhadap Y, turunan F terhadap Z. Karena apa namanya? Kita perlu mencari grad F ya di titik P0, kemudian kita evaluasi di titik P0. Ternyata kita dapat itu ya. Ini kalau asumsinya turunan yang saya lakukan ini benar ya. Saya nggak tahu ini benar apa enggak. Kemudian kemudian kita cari arahnya, ya, arahnya itu harus vektor satuan, ya. Maka ketika kita diberikan arah vektor seperti ini yang ternyata bukan vektor satuan, kita cari vektor satuannya, kita dapat arahnya itu, baru kita masukkan rumusnya. Di mana ds-nya, distance increment-nya di sini adalah 0,1 unit.
Ustaz,
Ya.
yang tadi itu kita cuma pakai yang 3-nya itu, Ustaz.
Yang mana?
Itu kan hasil 9, Ustaz, 9 per 1000 sekian. Nah itu 9-nya itu dari 3 kali 3 yang awal itu atau keseluruhannya,
Ya,
Ustaz?
dari 3 yang awal aja, karena ini kan 4 kali 6, 24 ya. Kemudian ini dikurangi 12 kali 2, ya, dikurangi 24, 0. Maka yang ini saling menghilangkan, kita tinggal punya yang depan aja.
Oh, jadi berarti kalau ada yang sama tinggal dicoret aja.
Ya.
Siap.
Okay. The next problem. Find the linearization of the function f at each point. Yeah. So we have two problems here. So to find the linearization, we first need to find fx, which is 2x, and fy, which is 2y. Then in this case we have f at, so to answer the first question, at 0, 0, we have that f 0, 0 is 1, and fx at 0, 0 is 0, and fy at 0, 0 is also 0. So in this case, the linearization around 0, 0, L x, y is basically 1 plus 0 times x minus 0 plus 0 times x minus 0, which is equal to 1. And for the second one, at 1 comma 1, we have that f1 comma 1 is 1 plus 1 plus 1, 3. Fx at 1 comma 1 is 2, and fy at 1 comma 1 is also 2, because 2 times x and 2 times y. So here the linearization Lxy is equal to 3 plus 2 times x minus 1 plus 2 times x plus 1, x minus 1 also. Then we have, oh, this is not x, this should be y. So here we have 2x plus 2y, 3 minus 2 minus 2 minus 1. Yeah, that's it. Any question for this one? It's very simple, I think.
I think okay.
No?
Very simple.
Okay. We just need to follow the formula. Yeah.
Yes.
And now this is a little bit harder problem. We estimate the maximum error. And here I already gave the answer. Yeah, the maximum error is this approximately 0.31. So I need this formula. So here we have that t x is equal to e power y plus e power minus y, and ty is equal to x times e power y minus e power minus y. So from here we have that tx is equal to 0, and ty is equal to x times e power y plus e power minus y. And also let's use the first one to find txy, which is also equals to tyx. This is equal to e power y minus e power minus y. And here we have that x and y are 2 and ln 2. So if we evaluate at 2 comma ln 2, we have we have 0, and this guy, if we evaluate at 2 comma ln 2, we have 2 times 2 minus 2 plus half. This is 5, I think. 2 plus half, yeah, 5 over 2. Yeah. And this guy, if we evaluate at 2 comma ln 2, is equal to this is equal to 3 over 2. 3 over 2, yeah. So in this case, the maximum is 5. So in this case, we have that m is equal to 5. So what we need to find is the error. The error is less than or equal to 5 over 2 times x minus x0 is basically dx, plus y minus y0 is basically dy squared, which is equal to 5 over 2 times the norm of dx is 0, 1, plus norm of dy is 0, 0.02 squared, which is, in this case, we have 5 over 2 times 0, 0.12 squared. Then in this case, we have I think I made a mistake. No, this is correct. Where's my cursor? Okay. 2 and ln 2. Oh, maybe we need to use the other equation. Differentials. Oh, this is... The upper bound for this guy let me check the curve first. Yeah, e power y plus e power minus y. No. Well, I think I made a mistake somewhere, because the value in this case is not the same as 0.31. I forgot where I put that, so let me put it on hold. Yeah, this is my homework for you. Okay, any question? Basically, the idea is like this. Yeah. Yeah, the idea is like this. Oh. No. Okay. So I think I know where I made a mistake. This is not like this. So this should be we evaluate at maximum possible error. Okay, so we evaluate at 0,1 and 0,02. So here 0,1 and 0,02, 0,1, 0,02. So if evaluate here, we have that. What is the value of e power? Let me find it. Calculator. exp 0,1 times exp 0,02 plus exp minus 0,02 is this is about 0,2, and the next one is that guy. I think this is minus. This is about 0,04. Yeah. So m here is 0,2. And well, let me check it later. Yeah, I think I made a mistake somewhere. But the first guess supposed to be correct. Well, anyway, if any one of you find that this maximum error is 0,31, then that should be fine. Yeah. Any question?
I think no, sir.
Okay. Then that will be my homework, not your homework. Now we go to the next material that is about extreme values and saddle points. And sadly, the materials is not fully ready in English, so this will be mixed between English and Bahasa. So the overview, we have derivative test for local extreme values, and then we have maximum and absolute maximum and minimum in closed and bounded region, and then some exercises. So we have actually the same similar construction of definition for local maximum and local minimum. Basically, if we have f that is a function that is defined on a region R containing the point a comma b, then f at the point a comma b is a local maximum of f if this happen. Yeah, this makes sense. Yeah, local maximum is meaning that the value of the function at that point is always higher than or equal to the function at other points around it, and the local minimum is the other way around. And okay, there is the theorem stating that, okay, if the function f has a local maximum or minimum value at interior point a comma b of its domain, and if the first partial derivatives exist there, then the first partial derivatives are both zero. Ya, jadi ini kita pakai cara yang sama seperti fungsi satu variabel. Ya. Untuk mencari lokal maksimum atau lokal minimum, maka kita harus pastikan semua turunan pertamanya harus sama dengan 0. Jadi kita cari titik di mana semua turunan pertamanya sama dengan 0. Kalau salah satu saja tidak 0, maka dia bukan lokal maksimum atau lokal minimum. And we have also critical points, yeah? An interior point of the domain of this function where both the function is zero, where both the first partial derivatives are zero, or where one or both does not exist, then that point is called the critical point. Ya. Sama seperti sebelumnya di fungsi satu variabel. Kalau semua turunan parsial pertamanya itu 0 atau tidak ada, atau salah satunya saja tidak ada, atau bahkan keduanya tidak ada, maka di titik tersebut kita punya titik kritis. And we have the saddle point. What is a saddle point? Saddle point is a critical point that is not, well, at that critical point, some of the values, around it, it may have values that is lower and higher. Jadi kalau saddle point atau titik pelana, itu maksudnya dia titik yang dia bisa jadi turunan pertamanya itu 0, makanya dia titik kritis, tetapi di titik tersebut nilainya itu bisa jadi lebih kecil dan bisa jadi juga lebih besar. Maksudnya di sekitar titik tersebut, di salah satu sisi kita menemukan nilai yang lebih kecil, di sisi yang lain kita menemukan nilai yang lebih besar di sekitar titik tersebut. Maka kalau seperti itu, titiknya disebut titik pelana atau saddle point. And this is the second derivative test for local extreme values. This is where you need to understand. Ya. This is the part that you need to understand. Jadi bagian ini adalah bagian yang kalian perlu pahami, karena ini yang akan sering dipakai ketika menjawab soal kuis ataupun UAS nanti. Ya. So the theorem says that suppose that the function f and its first and second partial derivatives are continuous throughout a disk centered at the point a comma b, and fx is equal to a comma b. Fx and equal to fy at that point that is equal to 0, then we do the second derivative test, which, okay, f has a local minimum if these two conditions hold. Maximum, f has a local minimum if these two conditions hold, and saddle point if this one condition hold, and the test is inconclusive if this fxx fyy minus fxx times fyy minus fxy squared is equal to 0. So in this case, we need to find another way. And this expression, yeah, fxx times fyy minus fxy squared is called the discriminant or Hessian of the function f. Jadi teorema ini, uji turunan kedua ini yang kalian penting untuk diketahui ya, karena ini akan banyak dipakai. di hampir semua bidang. Kalau kita mau mencari nilai maksimum lokal atau minimum lokal atau titik pelana, maka kita lihat apakah syarat ini dipenuhi. Dia punya maksimum atau minimum lokal kalau diskriminannya positif, baru kita tentukan maksimum atau minimum lokalnya berdasarkan turunan parsial kedua terhadap X. Semua ya, fxx. Dia punya saddle point kalau diskriminannya itu negatif. Kemudian uji turunan kedua itu tidak bisa kita gunakan kalau diskriminannya sama dengan 0. Ya. Maka kalau uji turunan kedua tidak bisa digunakan, kita perlu cari pengujian yang lain. Now, this example is still in bahasa, but no problem. Yeah, so in this case, we are asked to find the extreme local values of this function, and we need to determine whether it is local maximum, local minimum, or saddle point. In this case, we will use the second derivative test. So to do the second derivative test, we need to have fx, which is 6x x plus 6y, and fy, which is 6y minus 6y squared plus 6x. So from here we have that fxy, which is equal to fyx, which is equal to 6. And we have fxx is equal to 6. Yeah. fxy, fyy is equal to 6 minus 12y. Now, to find the critical point, oops, this is minus, so this is minus x. Yeah, sorry. So fxx is minus 6. To find the critical point, we make fx, which is equal to minus 6x plus 6y equals to 0, and fy, which is equal to 6y minus 6y squared plus 6x also equal to 0. From here we have that minus 6x plus 6y equal to 0. Then in this case we have that 6x equal to 6y. So from here we have that 12y minus 6y squared equals to 0, meaning that 2y minus y squared equal to 0, which means that we have 2 minus y times y equal to 0, which means that we have y equals to 0 or y equals to 2. Then now, if y equals to 0, then we have that from here is we have x equal to y, then x equal to 0, and if y equals to 2, then we have x equal to 2, meaning that the critical points are 0, 0 and 2, 2. Now we find the Hessian f(x(x) times f(y)y) Hessian minus fxy squared is equal to fxx is minus 6 times fyy is 6 minus 12y, and minus fxy squared. Fxy is 6 minus 6 squared, which is equal to minus 6 minus 12 12 times. So this is 72y minus 36 minus 36 minus 72, or this is equal to 72 times y minus 1. Yeah. Let's say this is equal to star. Then at 0, 0, we have that fxx is equal to minus 6, which is less than 0, and and the Hessian star is equal to 72 times 0 minus 1, which is minus 72, which is also negative. Then in this case, we can conclude that this is a saddle point. So at 0, 0 is saddle point, and at 2, 2, we have that fxx is again negative 6. That is negative, and the value of the Hessian is 72 times 2 minus 1, which is equal to 72, which is positive. And since we have that the Hessian is positive and fxx is negative, Hessian is positive and fxx is negative, then we have a local maximum. Yeah. Then in this case, we have a local maximum. Any question? Ya, prosesnya kita cari titik kritis ya, atau kalau di sini saya cari turunan parsial pertama, kemudian dari turunan parsial pertama kita cari semua turunan parsial keduanya. Setelah itu kita cari titik kritisnya dari turunan parsial pertama, kita buat sama dengan 0, ternyata kita dapat dua titik kritis, yaitu 0,0 dan 2,2. Kemudian kita hitung Hessiannya atau diskriminannya, yaitu ini ternyata kita dapat diskriminannya adalah 72 kali Y-1. Kemudian kita evaluasi di setiap titik kritis, dia akan seperti apa. Ternyata di titik kritis 0,0 Hessiannya negatif. Kalau negatif, maka kita bisa simpulkan dia adalah titik plana. Kemudian di titik 2,2 ternyata Hessiannya adalah positif. Kemudian kita bisa cek turunan parsial kedua terhadap x, ya, fxx, ternyata negatif, maka kita punya lokal maksimum. Ya. Ada pertanyaan?
I think no, sir.
Okay. Now, absolute minimum and absolute maximum. So absolute maximum and absolute minimum on closed and bounded region. Yeah. So these are the steps. So to find extreme values in a continuous function f in a region R that is closed and bounded, then first we find the interior points where the function has a maximum and minimum. Yeah. So it means that we need to find the critical points of f, and then we list also the maximum and minimum values on the boundary. Then that's it. Then we simply need to find which one that is the absolute maximum or absolute minimum. Yeah. Let's jump to this example. Yeah, I believe I don't need to explain to you in Bahasa for now because you already read the question in and also explanation in Bahasa. So in this case, we are asked to find the absolute maximum and minimum values of the function f in a triangular region in the first quadrant of xy plane that is bounded by the lines x equal to 0, y equals to 0, and y equals to 9 minus x. In this case, first we find the interior points. Yeah. The first step interior points. For this, we have, okay, since we know that this function is differentiable through for all points in the xy plane, so we simply need to find its derivative, its partial derivative. So fx is 2 minus 2x. We must make it equal to 0, and fy is equal to 4 minus 2y. That is also equal to 0. From here, we have that the critical point uh, 1,2 ya. Jadi kita pertama mencari titik interior. Untuk mencari titik kritis di interior, ya. Ternyata kita dapat titik kritisnya adalah 1,2 dengan cara kita menyelesaikan ini 2 min 2x sama dengan 0 dan 4 min 2y sama dengan 0. Then we simply need to check whether this point is in the triangle. So basically we have this line, and let's say this line. We have this line is y equals to 0, and this is x equal to 0, and y equals to 9 minus x, and the area is this part, this shaded region, and 1,2 is somewhere here, so it satisfies the condition, ya. Jadi kita harus memastikan titik kritis yang kita dapat itu ada di dalam area yang kita arsir. Then in this case we have that f at 1, 2 is 7. Ya, kita masukkan nilai fungsinya di titik 1,2 ke fungsi atas ini. Ternyata kita dapat nilainya adalah 7. Then the next step, second step, we evaluate at the boundary point. So in this case, we take the triangle one side at a time. Yeah. So first we have at the line on the line segment. So here 0, and this is 9. This is also 9. On the line segment x equal to 0, then we have that f of x comma y, f of 0 comma y is equal to 2 plus 4y minus y squared. And here y is from 0 to 9, yeah, because we have y is from 0 to 9 up there, the vertical line. Then in this case we simply need to find fy, yeah, which is 4 minus 2y, and we make it equal to 0. Then in this case y is equal to 2. So on this line segment we simply need to compute f 0 comma 2, which is 2 plus 8 minus so this is 6, and we also compute the value at the boundary points f 0 comma 0, which is 0, and f 0 comma 9, which is minus 43. And then we compute on the line segment y equals to 0, and we have f x comma 0 is equal to 2 plus 2x minus x squared. 2 plus 2x minus x squared. So in this case we find the critical points by derivating this guy, fx, which is 2 minus 2x. We make it equal to 0. Then it means that x is equal to 1. Then again we evaluate f at 1 comma 0, which is 2 plus 2, 3, and evaluate at the boundary of this line segment. We also have f at 0 comma 0, which is 0, and f at 9 comma 0, which is minus 61. Now for the last line segment, on the line segment y equals to 9 minus x, then we put in the function f of x comma 9 minus x, which is 2 plus 2x plus 4 times 9 minus x minus x squared minus 9 minus x squared, if I'm not mistaken. Yes, that is correct. Then this function is equal to minus 43 plus 16x minus 2x squared. Then in this case, we find that f x of x comma 9 minus x is basically 16 minus 4x. We make it equal to 0. Then in this case, we find that x is equal to 4, which means that y is equal to 9 minus 4, which is 5. So now we have that f at 4, 5 is equal to minus 11, and at the boundary we have the boundary 0, 9 and 9, 0. We already compute them all. So now we simply need to find the absolute maximum and absolute minimum. So in this case, the absolute maximum is, okay, we have the values are 6, 0, minus 43, 3, 0, minus 61, and minus 11. So this is the absolute maximum. And minus 61 is the absolute minimum. Absolute maximum, and in this case this is the absolute minimum. Ya. Jadi prosesnya seperti langkah-langkah yang ada di slide tadi ya. Jadi kalau kita mencari nilai maksimum minimum mutlak di sebuah daerah tertutup dan terbatas untuk fungsi dua variabel, maka prosesnya adalah pertama kita cari di titik interiornya, kita cukup mencari ini saja, turunan f terhadap x, turunan f terhadap y, kita buat dua-duanya sama dengan 0, kita dapat titik kritisnya, kemudian kita kemudian kita juga cari titik-titik kritis tersebut di boundary points ya, di titik batas, yaitu titik segitiganya, yang kiri, yang bawah, dan yang miring. Nah, untuk mencari di titik-titik batasnya, karena kebetulan bentuknya segitiga, maka kita ambil satu sisi segitiganya itu kita analisis di setiap sisinya gitu ya. Pertama kita analisis di segmen garis y sama dengan 0, x sama dengan 0, yaitu di sumbu y ya. Segmen garis yang ini x sama dengan 0 yang vertikal. Kita masukkan x-nya sama dengan 0, ternyata kita dapat fungsinya menjadi 2 plus 4y min y kuadrat. Di sini, di garis ini kita cari titik kritisnya dengan cara kita turunkan. Cari turunan pertamanya dibuat sama dengan 0, ternyata titik kritisnya di garis ini adalah y sama dengan 2. Maka kita tinggal evaluasi di y sama dengan 2 di titik kritis, yaitu kita dapat 6. Kemudian kita masukkan juga nilai di titik boundary-nya ya. Di garis ini batas-batasnya kan dari 0 sampai 9 y-nya ya. Maka kita masukkan y-nya 0, gimana? Ternyata kita dapat nilai fungsinya 0, dan saat y-nya 9, ternyata nilai fungsinya adalah minus 43. Begitu juga selanjutnya di segmen garis y sama dengan 0, kita cari titik kritisnya, kemudian kita evaluasi nilai fungsinya di titik kritis dan di titik batas. Begitu juga di garis segmen garis y sama dengan 9 min x. Ini sebenarnya kita juga hitung f di 0,9 dan f di 9,0, tapi karena kita sudah hitung sebelumnya ya, f di 0,9 adalah min 43, dan F9,0 adalah min 61, maka ya sudah. Sebenarnya kita tidak perlu hitung lagi sebenarnya. Ya. Nah, baru setelah kita dapat semua titik-titik ini dan nilai fungsinya, baru kita tentukan yang mana yang absolut maksimum, yang mana yang absolut minimum. Ya. Ada pertanyaan? Tidak ada? Kalau tidak ada, contoh yang terakhir ya. So in this example, suppose that we have a delivery company, and this company only receive rectangular boxes, where the sum of length and girth is perimeter of a cross section atau keliling dari salah satu sisinya. The sum does not exceed 108 inch. Then we are asked to find the dimension of acceptable box of largest volume. Ya, jadi kita punya panjang dan salah satu keliling salah satu sisinya. Gitu ya. In this case, first we draw the box. And this is the cut. We cut this area. This is the length. And this is the girth. So we have that the volume is the volume here is okay, not yet. So here we have length and width and height. So the circumference of the girth is basically 2 times the width and plus the height. Then in this case we have that length, this is the length L, length plus 2 times W plus H is less than or equal to 108. But in this case, what we want is, since we want to maximize the volume, so what we want is that the length plus 2W plus H, plus 2H is equal to 108. And in this case, the volume is basically L times W times H, which is 108 minus 2W minus 2H times WH, or we have 108 WH minus 2W squared H minus 2WH squared. Now we find the first partial derivative to be equal to 0, so partial derivative of v with respect to w is 108 h minus 4 wh minus 2 h squared. This is equal to 0, and the partial derivative of v with respect to h is 108 w minus 2 w squared minus 2 minus 4 wh equal to 0, and from here you can try to find it later. I have computed it. We will find critical points. The critical points are 0, 0, 54, 0, 54, 54, 0, and 18, 18. So in this case, we find that the volume at 0, 0 is actually equal to the volume at 54, 0, also equal to the volume at 0, 54, which is 0, and at 18, 18, we apply second derivative test, which is, okay, we find VWW. This is equal to minus 4H, and VHH is equal to minus 4W, and VWH equal to 108 minus 4W minus 4H. So from here we find the discriminant VWW times VHH minus VWH squared, which is equal to this should be equal to 16 WH minus 16 times 27 W 27 minus W minus H squared. And here we have that VWW at 18, 18 is actually minus 4 times 18, which certainly negative. And the Hessian VWW times VHH minus VWH evaluated at 18, 18 is actually equal to 16 times 18 times 18 minus 16 times 27 minus 18 minus 18 squared. Yeah, this is positive. So from these two, we conclude that the point 18, 18, the point is maximum. Because VWW is negative and the Hessian is positive, then at that point we have a maximum local. Then we have that the dimension with the highest volume is the length is 36 inch and the width is 18 inch and the height is also 18 inch. With the volume, this should be around 11,664 inch cube. Yeah, and that's it. Any question? The procedure for this, ya. Jadi kalau kita punya soal seperti ini, ya, maka sebaiknya kita gambar dulu seperti sebelum UTS, ya. Digambar dulu, kemudian kita kasih label. Setelah kita kasih label, kita tentukan rumusnya, formulanya. Karena volume, maka kita punya volumenya seperti itu. Ya, karena kita punya aturan yaitu boxnya itu total dari panjang dan keliling salah satu sisinya itu tidak lebih dari 108 inci, maka kita punya seperti ini, ya. L tambah 2W tambah 2H itu sama dengan 108. Kita gunakan ini supaya rumus dari volumenya jadi lebih sederhana, maksudnya tinggal W dan H saja, tidak ada L lagi. Kemudian kita cari titik kritis, ya. Dari turunan pertama kita buat sama dengan 0, kita dapat titik kritisnya. Kemudian kita cek di titik-titik kritis tersebut menggunakan uji turunan kedua. Dari uji turunan kedua kita dapatkan bahwa apakah titik-titiknya itu maksimum atau tidak. Gitu. Ya, ada pertanyaan? If not, then this is the summary for extremum seeking, ya. So summary for max and min tests. So you can read this later at home. And for the exercise, we will do it after. We will do it in the afternoon session. Yeah. Any question? If not, then let me end this morning session. See you later in the afternoon. Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam. Thank you, sir.